Hi, I'm Larry Puckett, the DCC guy. Well, for the last couple of days, I've been just digging through all of your comments, and there's, close to 100 of them now. So I'm trying to sort out the stuff that I can actually work with as far as topics for future videos, because I'll be honest with you, there are some things in there that I might not be able to do. Signaling, for instance, I have my own signaling system that would not be compatible with the Digitrack signaling system. So I don't know of any way that I can set it up on the layout here and actually test it out for you. I'll give it some thought. There might be a way I can do it on the module or somewhere else. But for right now, I'm not sure how I can go about doing that. The same thing, Arduinos and Raspberry Pis. You know, they're an interesting subject. They're great for automation. I'm not so sure how much I can do on that because, you know, I looked into it a little bit, and it really is a hobby within a hobby, to be honest with you. And I'm not sure that I have the time to dedicate to trying to dig into that and figure out how it works. I think there's probably a lot of videos here on YouTube that delve into the subject. And there's also been quite a number of articles over the last 10 years or so, 5 years or so, on the subject in Model Railroader magazine and probably Model Railroad Hobbyist. So you might take a look there as well, and I'll see what I can dig up. But in the meantime, what I want to start with today, though, as I said in that video, is a look at motors. Specifically, how do you know if a motor in a locomotive that you plan to install a decoder in is electrically isolated and therefore safe to go ahead and hook up to a decoder? Because if you hook it up the wrong way and you haven't got it properly isolated, you're going to see the magic smoke come right out of that decoder wrapper, and it's not going to work for you anymore. We're also going to take a look at the question of setting up and wiring a motor so that it's going to go forward when your throttle says it's going to go forward, because there are different ways to do that, and you can end up with it wired backwards and the locomotive will go backwards even though your throttle says it should be going forward. So we'll take a look at that. It's a pretty straightforward, easy thing to do. Now for this video, I'm going to go ahead and focus down here onto the workbench where I've got a number of motors and locomotives and my voltmeter, stuff like that, all set up and ready to go. And we'll get started with that. But first, hit that little red subscribe button, and when the little bell comes up, click on it and click all. Thanks now. Okay, so let's go ahead and get started with this. What I've done here is I've got a couple of old open frame motors. Now these are typically what would have been used in the 30s, 40s, 50s, 60s, 70s, and up into the 80s in some cases, before we got into what are called the CAN motors. And the thing about these, they're very inefficient as far as things go. You'll very often will find these will draw anywhere from an amp to an amp and a half. So they're not exactly DCC friendly from the standpoint of all the current that they require, compared to a newer motor that typically is somewhere between 1/4 and 1/2 an amp for operations, or even lower. Some of them are super high efficiency. So things have changed a lot, and it's a lot easier on your decoders. And also it means that you have to have you don't have to have as many boosters to operate your model railroad, because each locomotive requires much less of the power that some of these older ones would have. Okay, let's go ahead and talk though then about the isolation. What do I mean by an isolated motor? Well, in a lot of cases with these older motors, what they did was, you can see there's a screw right here on the bottom, okay, and there's a screw hole right here on the bottom. Those were put there so that you can easily mount the motor itself to the frame of the locomotive. And you would, they just have a hole down in the bottom of the frame that went right up through there. And so you could put a screw in and attach the motor to the bottom of the frame. Now this worked out very well for another reason, and that is because they very often used that contact with the frame through this screw to provide power to one of the motor brushes. And in this case, you can see it very distinctively because we have right here a blue wire that is attached to one of these motor brush contacts, and is soldered directly to the frame itself. And then you would put, just put a screw right up through a hole in the frame into the bottom of this motor, and you would have electrical continuity right to the motor brushes that way. The problem is, if you go ahead and hook up the orange and the gray wires for your motor power from your decoder to these brush contacts like this, that's going to result in a direct short back to the track power. And you're going to burn out your decoder. The way you're going to know that as soon as it happens is you're going to see smoke in most cases come out of your locomotive. Not a good thing in this case. You're going to get a smell that's kind of funky. And when you take it apart, you're going to see probably a hole burned in the plastic wrapper. So those are the symptoms. Now, how do you deal with this? Well, in a lot of cases, the easiest thing to do, is I replace these old open frame motors with a can motor. And Northwest Shortline used to sell remotor kits. I think they still do. You can also check Micromark and see if they sell motors that you could use to remotor. And some manufacturers like that still produce Mantua locomotives and various other brands may have motor upgrades for your older locomotives. Bowser, for example, might have some remotor kits. For most of the situations, though, what you're going to have to do, even if you stick with one of these older open frame motors, the easiest thing to do is to take a piece of rubber, and you can use a piece of inner tube, something like that, or you could take some electrical tape, maybe put 2 layers of electrical tape on the bottom of your motor so that it is physically and electrically isolated from your frame. And then use a nylon or a plastic screw here to mount the motor to the frame itself. And that way you can electrically isolate it and not have to worry about that problem. It's always a good idea to check it afterwards, though. So let's go ahead and take a look at how do you go about checking to see if you have isolated the motor. Okay, this is an older Atlas S2 switcher. Let me pop the shell off here so we can get to it. And you can see it has a 5-pole motor in here. It's reasonably efficient. It's not skew wound, so it's not the best. And skew wound means that the armature plates here would be at a slight angle, and that makes for a much, much more efficient motor. But with this, at least it's 5 poles, so it's going to run reasonably smoothly. It might not be the lowest amperage, though. So these typically are pulling in somewhere between 3/4 and 1 amp themselves. So it's not all that efficient as far as compared to the newer versions of this very same model. So how do you know if the motor in this case is electrically isolated? Well, one way is to do a physical inspection. If you look here, you'll see that we have a metal frame for the motor itself. And that metal frame, we have a weight on top of it, and then this circuit board. Now, with this circuit board, we have wires coming up from the trucks, left and right track pickups, and they go to this little circuit board here. And in this particular case, there is a screw, metal screw, right here that holds this circuit board in place. So that metal screw goes down through this weight and into a hole drilled in the motor case itself. So that means that electricity from the right and the left tracks come up through the trucks, through these wires, to this circuit board, and then the right one here goes down through this little metal screw and is connected to the motor itself. So that's a bad sign right off. Also, if you look here on the bottom, and I doubt I can show you this, but right in here, there is another screw just like the one on the top. And it goes through the chassis and up into a hole just like this other one in the bottom of the motor frame itself. So we've got 2 points where power from the chassis is being routed to the motor. That's a bad sign. That's an indication that it is not electrically isolated. And it's a widely known issue with these older Atlas S2 switchers. Now, you can also take your voltmeter, turn it on to the ohms setting right here, and you'll have that little Greek omega indication here. Now, if you look at this, I'm going to set something under it so I can tilt it for you. So you can see it says 0L right there. Okay, that indicates that with this particular voltmeter set on resistance, that there is no connection between these two electrical probes that I'm holding here. Now, if I touch these together, it's going to go to 0. Okay, and that means that there is a complete connection between the two contacts. Normally, you can use this to measure resistance, and in this case, it's being used for a continuity, what's called a continuity check, because as long as there is continuity or electrical connection between 2 points, it's going to go to 0. Now, another neat feature on a lot of meters is, and on this one, let me click twice. When I connect these together, you will hear an audible alarm. I'm going to hold that up next to my microphone, hopefully so that you can hear that. And I'm going to connect them together. So you should be able to hear a high-pitched whine. So that is a continuity check. It's common on most voltmeters today, particularly digital ones. All you have to do is connect them together, and it indicates whether or not there's an electrical connection. So how can you use that to test your motors in advance? Well, let me show you. On this particular case, I'm going to just make a contact here and then make a connection to the frame, and you can see we're getting connection. So that's electrically connected. And if I touch this little circuit board, you can see the same thing. Right there, you can hear it. And you can see it's going to 0. So there, we know that there's a connection here between this circuit board and the frame. That's not a good sign. Now, let's touch this little screw here and hit the frame. And again, electrical continuity. That's not good. That means that this motor is not isolated. Okay, so how would I go about isolating this motor? All you have to do is take this screw out here on the top, take the screw out on the bottom, and this weight and the circuit board both lift off, and that exposes your motor, which you can then lift out. What I usually do is just apply a piece of electrical tape to the bottom of the motor, reinstall it, and use a plastic or nylon screw here on the bottom, and up here on the top, I get rid of this circuit board because there's other ways to wire this up, and we'll do that in a future video. But what I want to do is show you first the same type of operation with an Athearn locomotive. Okay, so this is an Athearn, I think it's a Jeep 39 or something like that. Jeep 50, I'm not exactly sure. It's been around for 20 years, I think. It's made by Athearn, readily available. And let me pop the shell off there. There we go. This is the basic setup for these. The headlight has been removed because I'm planning to add headlights to the front here. So basically then, what we have is our motor, and it is set into rubber mounts here on the bottom. And you can see those from the bottom here, the little rubber mounts. It's fairly straightforward. I use this one in particular because it's easiest to test. Let's test the actual motor itself. I'm going to get this down here out of the way. Okay, I'm holding the red lead against a bare spot here on the frame itself, and I'm going to touch one of the motor clips here on the bottom of the motor. So you can hear that little whine telling you that there is continuity, and you can see that the resistance is dropping down below 1, 1.5, and heading for 0. That indicates that the brush contact on this motor is physically and electrically connected to the frame itself. Now, the way that works is, and let me show you another motor that I've got here, another Athearn. And what I'm going to do is just lift that out of here, and you can see my motor mounts fell apart when I took this out of here previously. And somebody asked me about how to deal with this in a previous comment, and the easiest thing to do is take some good old silicone sealant that you can buy at the grocery store, the drugstore, big box stores, any hardware store, that kind of thing. And all you have to do is squeeze a puddle of silicone sealant here in the bottom and then set that motor back in it and prop it up with toothpicks or something and let that set up, and that'll give you a good motor mount. Athearn designed this system years and years ago to be able to use the frame as one leg of the electrical pathway. Now that's not DCC friendly and DCC compatible, so it's something we have to work around. Now the way that they're able to do this is they've got this clip here. This clip fits on over top of the motor brush contact. It's right under here. So let me pop that and I'll show you. Don't want to lose it. So you can see this spring right in here. Right underneath there is the motor brush. So that holds it firmly in contact. Okay, I'm going to push that back into place and clip everything back down here. Whoops, has to go the other way, excuse me. Just like that. Okay. Now the way that this works is Athearn cut a nice shiny spot here on the frame. You can see that right there. And on the bottom of the motor, let me zoom in a little bit. On the bottom of the motor, they have these two little pieces, spring-like things, sticking up. Now those two little spring-like projections sit down in this little slot that has been cut into the chassis, into the frame itself, and that gives it that electrical connection. So those sit down in that slot there against the bare metal, and they pass current to the motor brush right here. So that's how that works. So how do you avoid this clip problem? Well, there's several different ways. One thing you can do is you can either break these two little clips off, or you can take a screwdriver and press them down flat so that they won't contact the bottom of that slot on the chassis. Or you can take the one off the bottom and the one off the top and swap them so that these two little projections are on top and a flat, smooth clip is located on the bottom. And that's a very quick and easy way to do it. Another thing you can do while you've got those off is you can attach the two wires from the decoder here and here and put it back together and it'll be ready to go. Okay, the next question that I wanted to tackle was how do you know in advance whether or not a locomotive is going to go forward if you hook up the motor leads in a particular orientation? Because I just showed you that you can hook up your motor leads to these little clips here on the Athearn, and in all cases you should have a motor positive and a motor negative. And on a decoder, the orange wire is positive, the gray wire goes to the negative pole on the motor itself. But motors generally do not have that indicated. So how do you know? Well, there's actually a pretty easy thing to remember. The NMRA specifies that when a positive current is applied to the right rail, then the locomotive will move in the forward direction. So if I put a positive current on this rail, this locomotive chassis is going to go forward. And that happens to be that orientation. So in this case, if the Norfolk Southern has this designated as the front of the locomotive, we want this chassis to be able to go forward. So what I've done is I went ahead and hooked up my 9-volt battery to the red wire, and I've got my black wire separate, and I have a red and a black wire attached. So I've got the red wire attached to the right-hand rail, the black negative wire is going to go to the left-hand rail. So the motor is hooked up right now so that it will go forward. So right rail forward, that's what we're getting. Now what does that tell you about the motor? Well, if you follow the electrical path, that will tell you, therefore, which is positive and negative. So let's look at how that works. Okay, I've got my voltmeter again. I'm going to turn it on ohms. So what I want to do is find out which one of the motor contacts, in this case, is positive and which is negative. Okay, so as you can hear, with the red lead attached or connected to the right rail, I'm getting a continuity here to this particular contact on the motor. And that is connected to this top motor brush. So that means the top motor brush is positive, the bottom motor brush is negative. So hook up your orange wire to the top brush contact in this case, the negative wire, the gray wire, to the bottom contact, and you'll be ready to go as soon as you make provisions for track pickups. And like I said, we will go ahead and install a decoder in this locomotive at some time in the near future. And I'll show you how to go through all of this stepwise for an installation. But for right now, I just wanted to address these specific questions that folks have asked. Well, that's a wrap for today's video. Hopefully I've been able to give you enough information to tackle the job and figure out whether or not your motors are electrically isolated. Because if they're not, and if you hook up a decoder to it, you're going to let that magic smoke out, and it's not going to work again until it has a trip back to the factory for repair, assuming they can repair it. But as long as you follow the steps that I've laid out, you'll be able to safely install your decoders in old Athearn locomotives and various others that have been around for decades. Because, you know, there's just tons of these older Athearn locomotives available at swap meets and train shows and online forums, all kinds of places like that. Plus, you know, a lot of the locomotives that are still being made by Athearn outside of the Genesis series are very similar to the way that these are set up. So that should put you in good stead with how to go about testing your locomotive motors up front. And the same goes for a lot of others, you know, the older Atlas and Lifelike and Bachmann and various others. It's very straightforward, easy to do, so think about it and give it a try. So that's it for today's video. Have a great weekend, and we'll see you here next week with another video from the DCC Guy. Bye now.